Hi, Algebra 2. This is Unit 13, Lesson 4, and today's lesson is on the normal distribution and z-score. So Alex has a challenging course load taking physics and calculus. He got back his most recent exam grades in both classes and was disappointed with his performance. He began to feel better once the teachers reported the mean and the standard deviation for the class. When compared to his classmates, in which class did he do, quote, better? So let's think about what he actually got. So in physics, he got a 78, all right? In calculus, he got an 88. So it seems like he actually did better in calculus than physics because he got 10 points higher. But let's look at the mean grade. So the mean grade in physics was a 72. So let's actually subtract that. So physics... All right, he got a 78. The mean grade was a 72. So that's 6 points higher than the mean. The standard deviation is 1.5. So if I take 6 and I divide it by the standard deviation, 1.5, he was 4 standard deviations away. I can fit it in. It's 4 standard deviations away. Okay, but now let's look at calculus. Calculus, he got an 88, which was a higher score than physics, all right? The mean grade for calculus was an 82, so 88 minus 82 is 6. Now, the standard deviation in calculus was 4, so 6 divided by 4 is 1.5. So he was only 1.5 standard deviations away. So he actually did better in physics. He's much further away from the mean, meaning he did better than the rest of the class. All right, so he did better in physics. Much further from the mean. So that's how you can compare two different scores to their mean and taking into account the standard deviation. All right, so z-score. The z-score is the number of standard deviations a piece of data is from the mean. So I'm just reading this right here. A z-score is the number of standard deviations a piece of data is from the mean. If I have a positive z-score, that means that my score was above the mean. If I have a negative z-score, then my score is below the mean. So I have the formula right here for z-score. I'm going to circle it right there. The z-score equals x. Now, x is the value that I'm looking at minus the population mean. Okay, mu, we call that letter. It's like a fancy U right there. Divided by the standard deviation. So that's how you find the z-score. You will have one problem like that to do on the test. So to convert a value x to a z-score, subtract the population mean, then divide by the population standard deviation. So that was the formula that I just said. To find the z-score, you're going to take whatever score you're trying to find how far away it is from the mean. That's your x. Subtract the population mean and divide by the population standard deviation. Now, when we looked at the normal distribution, that 68%, 95%, and 99.7%, that divided the area under a normal distribution into sections with widths of 1 standard deviation. Those are great for finding percentages as long as you're dealing with values that fall at those exact subdivisions. But what do we do when the value does not fall at one of those subdivisions? So by using the z-score, we have the ability to locate a percentage or the area under a standard normal distribution at any location. So z-scores allow for the calculation of area percentages, also called proportions or probabilities, anywhere along a standard normal distribution curve and consequently along the corresponding normal distribution. So let's just practice a problem where I had to find z-score. Now you're going to have to change the problem was there. I was moving stuff around and I lost the problem that I actually wanted, which was the basic practice of just finding a z-score. So you can cross out the problem that was there. Exercise 3, I'm going to change it to in a normal distribution with a mean of 50 and a standard deviation of 6, what is the z-score if my score is 47? So what I'm going to do is 47 is my score. You subtract the mean, which is 50, and you divide it by the standard deviation, which is 6. So that goes into my calculator, and I got negative 0.5. So that means that my score is actually below the mean. All right, anytime I get a negative score, then my score is below the mean. Let's take another one, 65. So 65 is my score, and I'm trying to figure out my z-score. 65 minus 50, because 50 is my mean, divided by my standard deviation is 2.5. So I'm 2.5 above the mean. All right. Now the rest of these, though, now that you've seen what z-scores is, we can really just still use our calculator when we're doing this, but you will have a question that's just going to ask you to find the z-score. In a normal distribution with a mean of 56 and a standard deviation of 8, what percent of the scores lie between 48 and 64? So again, I'm using that second VARS normal CDF. So my lower score is 48. My upper score is 64. Just to remind you how to do this. My mean is 56. And my standard deviation is 8. So after I hit second VARS normal CDF, all of those are going in. 48, 64, 56, 8, hit enter, and I get 0.6826. And that's, I'm trying to find the percent of the scores. So I'm going to change that to a percent, 68.2%. Okay, so same thing that we've previously done on this problem. Same thing on this one. So my lower score is 56. My upper score is 68. My mean, it's the same mean that I had, a mean of 56. And my standard deviation is 8. And I get 0.433. So it's 43.3%. So there is a way, there's a table for z-scores that you can actually look up, but we can just do these right in the calculator. High levels of cholesterol in the blood increase the risk of heart disease. For 14-year-old boys, the distribution of blood cholesterol is approximately normal, with a mean of 170 milligrams of cholesterol per deciliter and a standard deviation of 30. What proportion to the nearest thousandth of 14-year-old boys have a cholesterol over 210? Again, can just do in your calculator. All right, so I want it over 210, so 210 is my lower number. My upper number is infinity, so I just put in a bunch of 9s. My mean is 170, and my standard deviation is 30. So I get 0.091211. Right, so if you want to pause the video and try that, make sure you can do these. What percent of the boys have cholesterol between 158 and 228? Same thing, calculator. So my lower number is 158, my upper number is 228, my mean is 170, my standard deviation is the same thing, 30, and I get 0.6288. And that's 62.9% when I move that decimal 2 places. If a doctor has 200 14-year-old boys in her practice, approximately how many would she expect to have cholesterol below 164? All right, so I have to find out that decimal, but I want to know how many people. So after I'm done, I'm going to multiply that by the number of people, the 200. So my lower number is going to be 0 because I want below 164. 164 is my top number. My mean is 170. My standard deviation is 30. So that gives me 0.420740. But that's the decimal, the proportion. I times that by 200 because she has 200 people. And it comes out to 84. So 84 boys she would expect to have cholesterol below 164. All right, I got 2 more problems to try. On a driving range, Tiger Woods practices his swing with a particular club, hitting many, many golf balls. When Tiger hits his driver, the distance the ball travels follows a normal distribution with a mean of 304 and a standard deviation of 8. All right, what percent to the nearest percent, so I want a whole number, of Tiger's drives travel at least 290 yards? So that means 290 yards or more. So in my calculator, same thing I've been doing in last lesson and this lesson. 290 is the bottom number. Infinity is the top number. Just a bunch of nines is fine. My mean is 304. My standard deviation is 8. And that gives me 0.9599. And I move my decimal over 2 places. So that's actually 96%, because to the nearest percent, I don't want a decimal. What percent to the nearest tenth this time of his drives are between 305 and 325? Same thing. So you can do this in a calculator. Obviously for multiple choice, for part 2s even, you just write calculator and you write the numbers that you're putting into the calculator, just like I am. 305 is the lowest number. 325 is the top number. The mean is 304. The standard deviation is 8. That gives me 0.445929. Move my decimal over 2 places. Now I want this to the nearest tenth, so that's going to be 44.6%. All right, and the average weight of a full-grown cow is 1,470 pounds with a standard deviation of 230 pounds. If the weights are normally distributed, what is the percentile rank of a cow that weighs 1,750 pounds? So you can actually do this the same way that I've been doing it. That's going to be at most 1,750, because remember the percentile, it's not that that's your score, that's the score that that many percent of people got at or below. So I'm going to do second, bars, normal, C, D, F, so 0. 1750 is my upper score. My mean is 1470. My standard deviation is 230. And I get 0.88827. So that is 89%. And that is it for this lesson.